the problems that is commonly asked in the companies like Amazon and Microsoft. Find the common element between the two sets. Let us say I'm having list 1, which is holding 1, 2, 3, 4, 5, and I'll take list 2 is equal to, I might have the 4, 5, 6, 7, 8. So now here you can see that, so this one I can do it in multiple ways. So first I'll do it in using for loop. Okay, so now I'm going to this is a question, maybe they might have given two lists, you might have to write a program where you will find a common elements between L1 and L2. Okay, so when you say L1 and L2 were here, let me say take one empty list which is going to hold the common elements. Okay, so now I'll say for I in list, this will iterate through the list, and that is L1 I'm considering first. Then I'm going to check if I in L2 and I not in the common elements. So first I'm trying to check whatever the I that is there in L1, then the same I which is there in L2. For example, if I'm having 1 in L1, and it is going to check if 1 in L2. So 1 in L2, it has to be there. You know that it is not there. So this is going to be false at that time. Now I'm going to say that you have used the AND operator. That means this has to be true as well, and this has to be true as well. So now I'll say for I in L2. Okay, so I in L2 and the I over here is not in common elements. That means it is not already added. Okay, so now it is going to check whether, first it is going to check whether I is in L2. So for example, if I take 1 is in L2, 1 is not in L2, so this will become the false for first one. So now if it is false, we don't append it to a common elements. For example, here let us say it will go to 4 in L2, that we know already, and 4 if till now we have not added anything to the common list. So I not in L2, and this is also true and this is also true. So now what I'm supposed to do is I'm supposed to say C dot append I. So if it's not there, it's going to append it. Otherwise, it's going to just print it. Just going to ignore it. So I'm going to say print. So let us say I'm going to have maybe C as a common elements. Let us execute this. So now you can see that if I execute it, and now we can have the elements which could be the n number of times that elements might already be there, right? That means list can have n number of 5, n number of 6 also. 4 and 5 are common elements. So this is one way. So let us add comma. So I'm adding some of the elements repetitive as well. Now you can see that 1, 4, 5 and 4, 3 are common elements, even though here we are having repetitive elements. So when I'm having repetitive elements, this is going to be false. So when this is false, this is not going to work. So now this is one way of doing it. And when I do this, since I'm using the for loop, here the time complexity is more. That means the time complexity over here is n square, because I'm going to use if inside the for over here. This is going to have a worst case scenario. Now let us see other way to do this. The other solution to do this would be, so I will convert this into set, and I'm going to find the intersection between that. So I'm going to say that S1 is equal to set of L1, and this is one way. Other way, what I can do is one, I can find the intersection. So intersection of I'm going to say that intersection between set of L2. Okay, so this I'm going to convert it into list. So I'm going to say that list of set 1 of intersection and set of L2. So if I execute this and let me print this yes 1. So now if I print this yes 1, same thing I'm getting over here 1, 4, 5 and 43. Here 1, 43, 4 and 5. So here the same answers we are getting the common elements, right? So this is the best case scenario where it is going to time the consumption, the time complexity is of n, we go of n, I'm going to get it. So now this is two ways. These are the two ways where I can work with finding the common elements between the list. Now let us go for the next problem, that is counting the occurrences of each element in the list. So now for example, they might have given a question like list is equal to 1 2 3 4 5 6. So now I'm having 2 twice, 1 again twice, 3 for 3 times, 4 for 4 times I'm having here. So now I might want to find the occurrences of each element, how many times it is present. I'll just remove these. Okay, so now let us see how we can find it out. To find the occurrences of it, so we have the sum methods, which is going to where I'm going to use the for loop, and without for also I'll show you. The first solution would be using a dictionary. So to work with dictionary, let us say I'm going to say that occurrences O is equal to, I'm considering the empty dictionary. So in empty dictionary, what I'm going to do is I'm going to say for I in list, I'm going to consider. So if I, that means whatever the I that I'm going to have over here, that means I, if it is in the list, if it is in the occurrences. So now you can see that I have taken this is the question that they have given, and they have told us to find the occurrences of the individual unique values that we are having. So I need to find how many times 1 is present, how many times 2, how many times 3, how many times 4, and how many times 5 is present. So for that, I'm going to say that if I'm just looping through the list now. Inside the loop, when I loop through it, the first one, if I is in occurrences, that means if it is in occurrences, that means it's going to concentrate on the key. Because when I say, for example, if I have the dictionary D is equal to key and value V, and then I'm going to say key 1 and value v1. So if I say for I in dictionary, I'm going to check if I equal to k. Okay, so print k, else I'm going to say print I. So now let us see what is going to print it. So when I execute this, v1 not defined because I need to put it inside the single quotes. So now if I execute this, it is printing me k1 and k2. That means when I say for I in D, it is concentrating on the key. Okay, so for if I use I is equal to k, right now it is concentrating on the keys, right? So in the same way here, what I'm doing is if I in occurrences, that means O, occurrences O, I'm going to say that if it is there already, I'm not going to create new one, I'm going to add it. That means if it is in that already, I'm going to say that occurrences of I. So I means, for example, so now you can see that O is empty, isn't it? O is empty. So for that, I'm going to say that for I, O is empty, and first thing I'm going to go ahead with is 1. So if 1 in O, is it there? 1 in O, is it there? 1 is not there as of now, right? So I have to write an else statement. For that, now what I'll do is I'm going to say that O of I equal to 1. So initially, the right now I just encountered 1. So I have added the value 1 over here. So now what just created was, so right now it just created O. In that dictionary, O is equal to, so 1 it has got created, and the value is 1 over here. So this is how it got created. So right now, because the occurrences of 1 is not yet there in O, so it will execute this else part. So when it executes this else part, it is going to create this. Okay, so next it will go to 2. So it will go to 2, and you can see that 2 is not there in O. So it will come to else part. So it is going to be 2 and 1. So 2 is present for one time. Next it is going to repeat the same thing. So now 3, 1 it will happen. Next 4 it will go. So 4 again same thing. So 5 again same thing. So now it will go to 1. 1, and it checks whether 1 is in occurrences. We know that it is already in the occurrences, right? So since it is already in the occurrences, now what I am going to do is O of I. That means I'm going to access this key, and I'm going to say that plus 1 to it equal to 1. That means I'm adding 1 to it, because 1 is already there. I'm incrementing the count of 1. Next it will go to 2. So when it goes to 2, 2 is already there. So now it has become 2 like this. 2 is already there, we know that. So I'm going to increment this 2 as well. It find out 3. So 3 is already there, so increment it to 2. Next it went to 3 again. 3 is already there, incremented to 3. It will go to 4. 4 is already there, incremented to 2. Next it is 4 is already there, incremented to 3. Next it will go to the next 4. It will increment to 4. So this is how we are supposed to get the output. Let us see if this is the same. Now I'm going to print O. So if I print this O, you can see that 1, 2, 2, 2, 3, 3, 4, 4 times, and 5, 1 time. So this is how we can find out the occurrences of each element inside the list. And this was a question which was asked in Google and Facebook. So this is how you can just think and explore and continue. So now I hope everybody understood about this particular uh, problem. So now let us move on to the next problem, that is removing the duplicates from the list. So now this question was asked in the companies like IBM and Cognizant. To remove, we have multiple methods. So we have seen one method over here, the dictionary method, and one more method we'll see. I'll take it down as an assignment, the one more method. So now remove the duplicates from the list. Let us see how we can remove the duplicates. To remove the duplicates from the list, let us say I'm having list is equal to 1, 2, 3, 2, 1, 2. Okay. So easily I can remove, I can convert it into set. So I'm going to say that list L1 is equal to set of L, and I'm going to print this L. This is the most easiest method. So one more method, you can use the for loop and you can do it. Let us use the for loop. So that will be having the time complexity more. When you are using the inbuilt data structures like this, the time complexity would be lesser compared to when you work with for loop. So now you might have thought that I'll iterate through it and then do it. So the people would be looking for your better code. So it has to be, the time complexity should be lesser and space complexity should also be lesser. Now let us see about the finding out the duplicate items and removing it by using a for loop. So first I'm going to say that unique list is equal to empty I'm taking. So now I need to find out the duplicates were here. So for that I need to iterate through it. For I in L, okay, so now I need to find out whether that item is not there in the unique list. So I should not be there in the unique list. If it is not there, I'm going to append it. If it is there, I'm going to skip it, just like we did it over here. So I'm going to say that if I not in is a membership operator which is going to check whether it is not in. If you are using in method, it is going to check whether it is in. So now not in, I'm going to say unique list UL that I've taken. If it is not there, I'm going to append it. So unique list dot append. So append that I, else I'm going to skip it. So if I print this UL now, it is going to consider only the unique items. So now I have printed UL and you can see that I'm getting 1, 2, 3. So this is the worst case scenario and this is the best case scenario, because whenever you use the for loop, it is going to increase the time complexity by n or n square. Okay, so I hope this was clear. Let us move on to the next problem, that is check if two strings are anagrams. That means, so for example, if I'm having yes1 is equal to silent and I might have yes2 equal to listen. So you can see that listen and silent are having the same letters but in different order. So now when you see this, I might have to find. So for example, if I'm having listen, now these two are not anagrams. So when I say LISTEN, so this is anagrams. That means these value and these values are having so different orders but same letters. So now sometimes what will happen is you might have given capital yes and here capital L. Since it is case sensitive, it is going to consider that whether these two are like these two are not anagrams. So now first I'll write a program for both smaller. Okay, so now I have written a I'm going to write a program for all the letters which is in lowercase. Now what I'm going to do is I'm going to use a method called sorting method to work with this. So I'm going to say if, so sorted of string s1, and so we can say equal to check it. So sorted of yes2, if they both are equal, so what it will do is, for example, if I say print sorted of s1, now I'll execute this. So if I execute this, here you can see that it has sorted and kept it based on the value of alphanumerical value. Alphanumerical value means it's going to consider based on the ASCII values. So EILNST is having an ASCII value, like ASCII value. Based on that, it has sorted. So now I will check over here with if statement if both are equal. So for example, if I say over here as s2, so s2 will also print me the same thing because it is going to sort it. So now I'll come back to this particular value of if it checking. Okay, so if sorted of yes1 equal to sorted of yes2, then we're gonna say that print and they are anagrams. Okay, now I'm going to say over here else not anagrams. Okay, so let us make this as capital L and this as capital yes. Let us execute this. So when I execute this, it is saying not anagrams, because here you can see that capital yes is having an different ASCII value and small yes is having a different ASCII value. So if I make this also as something like this, not anagrams, it's going to give. So now what I can do is I can convert it into lower before sending it. So no matter what the user says, I can say that dot lower. Okay, and if I'm applying the lower over here, here also I need to apply the lower itself. So now let us make this as capital yes and this as capital L. Let us execute this. So now it is printing me anagrams because I am checking for the lower version of all the values. Here I've converted to lower and then sorted. Same thing we have done it over here. So this is how we can check whether two strings are anagrams. Okay, so this is one method. Now the one more method, you can try it out by finding it using a for loop. So that would be an assignment.